So, good morning to all. Yesterday we started the stories. So, little bit now we'll go to actual class. Okay. So, these are the thing we already studied in the last class. So, these are the overview, basic concept, and then the stories we started with nice story, and then everyone realized what is the importance of the pipelines, and we talked about the speed up factor, and we have noticed that speed up factor is proportional to the number of stages. If we increase the number of stages, then we will have more what is called is a speed up. Okay. So, and then we talked about something, yes, we should have a cache memory, because there is need of continuous flow of instruction, otherwise pipeline will be stalled. Okay. So, but this is not the only reason that pipeline might be stalled. Okay. That in the last class we have seen that for any reason, if the pipeline stalled, so that is something called hazard. Okay. So, and then we have seen in the last last class that we will get 3 type of hazards. So, that we will be discussing in today's class. Okay. But still the idea is not too complex. Okay. So, of the record is like if too complex, then I won't discuss here. Okay. So, these are the thing already I talked about, and then we have a pipeline performance, and then we had a equation to show this very simple equation, right. So, to show that is the pipeline speed up is proportional to the what is called is like number of stages. Okay. Yeah. So, this is something called, I said ki if for any reason if there is a disturb in the pipeline, so that is something called hazard, and there may be 3 kinds of hazard. One is called data hazard, if there is a dependency between what is called is like between the data access. Okay. And then we have a instruction hazard, if there is no continuous flow of the instruction because of the cache miss others. So, that is something called instruction hazard, and then at the end we say is the structural hazard if the 2 operation needs the same hardware, because we have only single hardware for that operation. So, one will be allowed. Okay. So, now we will be talking about in details. So, data hazard. Okay. So, very related term you have studied in DBMS, I said, right. So, let us say suppose a couple, okay, let them, okay, they are married. Okay. So, they have account, joint account, and they can access the individually also. Okay. So, there is like a fight between them, and then what they will do, they will try to take out the entire money. So, let us say we put more money 2 millions in the account. Okay. So, now if they reach to the account, okay, in the next day in the bank, if they try to access from the 2 different counter, if everyone take out the 2 million account 2 million money, so then in total they will get the 4 million money, but it was in the account it was 2 million. Similar problem you must have accounted in DBMS class. Okay. So, here is quite similar, is like a data hazard problem. So, in that scenario what you do, you must have studied that there is something called exclusive lock. So, for any updates it has to be locked, and then only it will, that operation will be consistent, otherwise there will be inconsistent. Okay. So, here is similar problem we will see in the data hazard. Okay. Let us say here the example. So, here we have a instruction where we basically want to add, okay, and here we have another instruction where we want to multiply. Okay. So, what is the relation between 2 instruction is like whatever you are it is written, same is the operand here. Okay. So, in this scenario what will happen, say suppose value of, ideally if it really execute nicely in sequentially, first we will allow to execute A and then followed by B. So, you take any value of A. So, let us say A value is 8. Okay. So, then total B value will be 44. So, that is the that we expect. Okay. So, if it is not the case, if the both guys see that there is 2 million money and then both of them try to deduct at the same time. Okay. So, everyone will get 2 million and then it will remain 0 in the account. Similarly, even though if you see the value here, so A read is the value is 4, B is also read the value 4 and then B will be 16 and A will be say 7, but this is wrong. Okay. So, this is similar problem will happen in pipeline. Okay. How that we will see. Okay. So, but this is a different scenario. So, here there is no link in the operand. So, A is not here. So, then this operation can go smoothly. Okay. So, here, so when two operations depends on each other, they must be executed sequentially in the correct order. So, A should be allowed first and then only B will be allowed. Okay. But we are not doing so, because in pipeline that when A started executing, B is also started executing after one clock cycle. Okay. But what is the correct sequence? What should be the right results? So, A should be allowed entirely, then only B will be allowed for this scenario. Okay. So, now we will see that what happened, what is the problem exactly. Okay. Let us say we have two instruction. So, in one instruction what is happening? We are multiplying R2 with R3 and storing the result to R4. R2 we are multiplying with R3. And similarly, here what we are doing, R6 equal to R5 plus R4. This is so simple equation. Okay. Now, we want to execute these two instructions in pipeline fashion. So, what will be the problem? Let us say this is the multiplication instruction, there is no other instruction, let us say for simplicity. So, it will fetch, then decode, it will execute and it will write back. Now, while happening decoding here, the second instruction, what was the second instruction? So, second instruction was R6 equal to R4 plus R5. So, then what will happen? So, second instruction is fetched, and while second instruction is getting decoded and then first instruction is getting executed. So, now what will happen? So, after decoding it will realize, decoding as I said in the class, decoding is not only decoding, it will also bring the operand necessary for the execution. So, what are the operand here? These are the operands, these R4 and R5. So, R4 and R5 should be brought to the processor, okay, for execution. Processor means it should be ready for the execution. Execution is mostly happen in ALU. So, it should be ready before the ALU. So, therefore, after that what will happen? These two operand must be available here after the decoding unit, because after that there is execution unit. But what will happen? It will realize that R4 is not yet to write to the register file. So, therefore, it should wait until or unless that execution of not execution, if the write back phase is completed by the previous instruction. So, therefore, it should wait once it is written to the R4 by the previous instruction, that is multiplication, and then only again it will fetch that R4 value. It will fetch from where? From register only, within a processor from register to just before the ALU. And then what will happen? So, after that execution will continue. So, his question is why the second instruction will fetch the R2 before completion of W1. That is his question. Yeah, that should be. But thing is that this part what will ideally it should do? It should execute it here. But it is not ready to, it is not written to the register R4. So, therefore, it should wait and then again it start fetching the operand here, and then only it will go for execution. So, ideally what will happen? Ideally what we show, what we have seen, ki it should be execution here, right. That is, if pipeline goes more smoothly, it should be execution here, no doubt. But thing is, why it is stopped? Because there is a dependency between that R4 in the previous instruction. So, it is R4, R2, R3. Okay. So, R2 into R3. So, R4, that is the result is available, but result should be written to the register R4, that is yet to complete. So, therefore, it will store here according to the continuous flow of what is called is continuous flow of the instruction. There should be a execution unit here. Second instruction will be executed at the clock cycle 4th, but this will not happen. Why this will not happen? Because the operand of the second instruction is linked with the first one. First one is yet to complete, because instruction has 4 phases. So, right phase is not completed. So, after completion of the right phase, only that data will be brought to the just before the ALU. Your question is like this phase will start from here. Yes, okay. So, phase will start from here. Okay, that is the classical. We yesterday we told ki it will take much longer time. Okay, so life is very smooth, but it will take too much long time. You cannot afford. So, your program C equal to A plus B will take say let us say 1 minute. So, to get the advantage, we want ki the 2 instruction will executed concurrently. It is not parallelly. 2 instruction will executed in interleaving fashion. Okay, when this instruction is started, other instruction will start also, and the execution of this part and this part is it will not happening parallelly. If you see carefully, when instruction is in execution, another instruction in decoding phase. So, after decoding phase, it will realize that it needs 2 operand. One of them is actually depends on the just previous instruction, which is yet to complete. So, in that case what will happen? It will stop here. So, it will stop here. So, therefore, it will be delayed. Otherwise, what will happen? So, both will take out the $2 million. So, one has to wait, and then others should be allowed. Otherwise, results will be wrong. So, once that first instruction is like here, let it complete first. So, let us say A equal to 4. So, A results of A will be stored, and then B will be allowed. So, therefore, what will happen? That second instruction A should wait here, and after completion of this one, again it will fetch, because the data is updated data will be fetched, operand will be fetched, and then it will go for the execution. So, in the process what will happen? So, that 2 time unit, it is taking more 2 clock cycle, that it is not effectively being used. Ideally, what should have been done? Ki D2, then it will be E, and then when E, this will be D, okay, and then when it will be write back, it should be execution. So, this 2 cycle will be wasted. 2 cycle is stalled. Why? Because there is a data dependency. So, now we will solve this problem. Okay, how this problem can be solved? So, in DBMS we have used the something called the log. First you need to understand the problem, then only you can solve the problem. Okay. So, if you feel okay, I understood the solution, but I did not understand the problem. Why every instruction start? So, it cannot start, because decoding is yet to complete, because it is not leaving that decoder unit. So, once it leaves, then only it can start. When D2 is completed, then only this unit will be free, then only one can use. D2 is again, it is a part of decoding. As I said, the decoding is, it will understand what the instruction is, and second part key, it will bring the operand also for the execution. So, it is yet to complete that part. So, that therefore, is even I3 cannot start for decoding, only fetch is completed. Okay. So, these 2 will remain like that, and even Actually I4 should have started at the 4th clock cycle, but it is starting at the 6th clock cycle. These 2 cycle actually it remain stalled. So, this is the hazard. So, now we should solve the problem, but underlying structure is the result should be correct. Result means if we run the sequentially, whatever the result we will get. So, even though if we go through the pipeline structure, result will be identical. We cannot tell because of the pipeline, okay, some error might be allowed. So, that will not work. Okay. So, now we will try to see what happened, what exactly see here. See what happened this figure, then we will explain the earlier one here. What happened? So, this is execution unit for first instruction. If you carefully see, okay, let me write it here. Here, so let us say 1, 2, 3, 4 cycles, and the instruction is first instruction. So, that was multiplication. Okay. So, it started with fetch, then it is decoded, second instruction on the way. Okay. So, this is what do we write is, yeah, fetch, second instruction, this is decode, then this was write, and this is again decode. So, this is execution, right. E1, so this is also D1. Okay. Up to this one there is no problem. So, after that it is for write back, and it cannot go for the execution because operands are not available, but execution of the first instruction completed. So, therefore, whatever the results is available here. What happened, that write back is yet to complete. So, this part is yet to done. Okay. So, this is like this is completed, that means result is available, and for second instruction what will happen, second instruction decoding is done. So, it is waiting for the execution. That means key execution unit is free. Why it is waiting? It is waiting for the results which should have been written, but execution unit is free. So, for second instruction, see, you see execution unit is free, these results is also available. What is this one? This is the fetch of the operand. There are 2 operands. So, one is R4 and another is R5 for second instruction, R5. So, R4 and R5. So, here R5 is there, R4 you cannot bring because it is not written, but result whatever it will be written to R4, that result is available here. So, what is done is that particular results can be fed to the execution unit. So, earlier we had R5 and now we are getting the results R4. R4, here we have the register R4. So, after writing only we will get this data. Instead of taking data from here, what we can be done is immediately after the execution, whatever the results is there, so we can take out the results and we can feed to the execution unit. So, this is the climax of the story. So, I said ki writing is not yet to complete. So, writing is not complete means after this part what will happen, R4 will have some value. So, that is let us say 32. So, that 32 is available here actually. What we can do it, whatever it is available we can take it out and then we can put it here to the execution unit. Execution unit is nothing but the ALU. So, then after immediately it can go for the execution because operands are available. So, then there would not be any stall of the pipeline. First we need to understand this part, then we will go to this figure. So, what happened here, instead of taking the results from the register file, that is R4, we are taken just before of that. So, that is the simple. So, instead of waiting for next step, you take out the results and then you forward to the at the required place. So, that is this technique is called the operand forwarding. So, this is something called operand forwarding. We are forwarding the operand to the appropriate place, so that the pipeline will not be stalled. So, now we go to the much more details here in this figure. Okay. So, what is there? We have ALU. So, you can say this is the execution unit. Okay, it is written ALU. So, this is, you can say this is the execution unit. Okay. And results is somewhere here. So, this is the results. Okay. So, after the write unit, so this result will be stored where? In register file. So, R4 is here. One register is called, register is there, is called the R4. So, this result will be written here at the stage W. In write back stage, this result will be written. Result is available here. To write the results from this flip flop to this flip flop, or sorry, this register to this register. So, there is a stage is called the write. So, now what will happen for instruction R2? Instruction R2 is what? So, instruction R2 was R6 equal to R4 plus R5. That is the second instruction, that is add instruction. So, it is fetched here, then it is decode. So, it is decoded and it realized it has two operand, that is it has to be add operation. It realized that is R4 and R5, and there should be a unit to understand that R4 is actually dependent on the previous results. So, therefore, what it will do? It will not take the results of R4. However, R5, whatever the value of R5, it will come any one of the register. So, let us say it is coming R5 here, and then it realized there is a dependency. Okay. You can check very simply, just previous instruction you see what are the destination and you check what are the operand. If there is any match, so then obviously there is a dependency, right. So, if there is a dependency, then it will use the operand forwarding technique. What is operand forwarding? Results will not be taken from the register file, it will be taken just after results register, this register after the ALU. So, therefore, what we will do it? You have a 2 mask, this is 2 to 1 mask. So, it can take the results from this line or it can take the results from this line. Similarly, it can take results from either from this line or either from this line. So, it realized that this instruction is one operand is here R5. So, therefore, it will choose from here, but it will choose from the operand forwarding technique. So, whatever the result is there, so it will go here and this mask will select only this part, not this one. Then what will happen? This result is available here and then R5 is here and then R4's results is available, not the content of the R4 register. It is taken from the register, that is RSLT, and then it will continue the operation. So, then there is no stall for the pipeline. We know mask, right? 2 to 1 mask, out of 2 it will choose 1, and if it realize that there is no data dependency, so then it will always take from, let us say from this part, it will take from this one. For this mask it will take S0 and this mask it will take from S1. So, this is the mask, right here. So, let us say this is something we say S0 and this is we say S1, and then it will select out of the 2, it will select 1. Either it will be select bit will be 1 bit only, either 0 or 1. If there is a operand forwarding for this mask, it will be selected. So, let us say here it will select 1, 0, or for this it will select 1. And if there is no data dependency, so then from here one operand will come. Let us say second example here, instead of R5, so let us say it is, so let us say R7. So, then R7 will come from here and then R5 will come from 5 from here, then it will directly come here and then result will be here. So, that is something called data forwarding. So, handling data hazard in software. So, but what is the just few minutes before whatever I said, key, it needs to, decoder unit needs to realize that there is a data dependency, okay, and then it needs the operand forwarding. Okay. So, this can be done by the software. Instead of in hardware, we can do in software. So, whatever code is written, compiler will transform it into appropriate part. So, there will not be an install, and it will realize there is a dependency, and then we can reduce the cost of the hardware, complexity of the hardware. Okay. So, this is one example. So, what you can do it, whenever it realize there is a dependency, put 2 instruction. So, that is something called NOP NOPU, that means it will not do any effective work. So, ideally what it will do, it cannot stop the stalling. So, results will not be any problem, because for that one also it should realize, no, there is a problem, and then you should stop. So, for that can be done using hardware, but you cannot stop this one. If that is the only solution, you cannot stop the stalling of the pipeline. For that one you have to go for the hardware solution. Okay. So, till now we talked about easy part, that is data hazard. Now, we will be talking about the other kind of hazard. Okay. So, that is something called instruction hazard. So, already I talked instruction hazard. So, if there is a, let us say what I said. So, there will be continuous stream of instruction in the pipeline. So, if there is a cache miss, means instruction will not be fetched. So, fetch will take much longer time. So, then subsequent all instruction cannot start. So, that is another reason for instruction hazard, is if there is any cache miss. So, now we will be talking about the instruction hazard. Okay. So, instruction hazard may happen just as few minutes before, if there is a miss in cache miss. Instruction is not there, how do you supply? This is so simple. So, therefore, you have to wait in the pipeline. This is one reason. Another reason may be if there is a jump instruction. You know what is jump instruction? Jump instruction is something like in C, even though people do not use much, is something there is a go to statement. So, go to in particular level. Okay. So, that is some unconditional jump, and there is something called conditional, when you put a condition, if I greater than 5, you do this one, else this part. So, in that case what happened, why it is called jump? Because it is not sequentially, it will not execute. In general, what we know that program executes sequentially. That condition is if there is no jump instruction. If there is jump instruction, obviously it will go to the desired instruction and it will be executed. So, for that also there is be stall in the pipeline. Why? That I will explain next. Whenever there is a stream of instruction supplied by the instruction fetch unit is interrupted, so then pipeline will stop. Okay. One example is cache miss, and another example is if there is branch. Cache miss is so simple, like you do not have instruction, then obviously it will be stopped, but we will see the branch. Okay. Yeah. Let us say, to make things simple, we have only 2 phases in the instruction. One is fetch, another is execution. Okay. So, within fetch everything is happening, let us say decoding is happening, and within execution plus write back is happening. Okay. So, we have 2 phases. Okay. So, this is a branch instruction. Okay. So, and it is unconditional branch. What do you mean by unconditional branch? I said ki explicitly it will be written that you go to the level, some level. Let us say this is level 1. So, you write increment R1 and so, and then level, so let us say you write 100, 200 and so on, and then let us say in 300 you wrote ki jump 100. Basically it is a loop, but without condition. After that it will move again in this portion and then again you go back. I do not know whether you have learned some kind of programming language in earlier. So, earlier people, let us say there are some programming language where you could use directly this kind of instruction, that is you go to, basically go to, instead of jump you write go to say level 100. So, this is example of jump instruction. Now, what happened after while executing this part, that is the branch. So, after that also you will have some instruction here. So, let us say this is 400 and then you write something increment R2. So, while executing this instruction, obviously it will execute the next instruction because that is the condition for pipeline. So, therefore, while executing branch instruction, this is called the branch instruction, followed instruction, that is I3 also will fetch. After realizing this execution part, okay, this is a jump instruction. Actually, it should have been executed the instruction INC R1, not the INC R2. So, therefore, you have to discard this instruction. Why? Otherwise, results everything will be changed. Okay. So, then again the instruction where it will be jumped, that instructions will be fetched and then executed. So, this is I am talking about the problem. Now, we will come to the solution. Same thing can be seen if you have a 4 phases. So, let us say this is the first instruction. So, first instruction will execute fetch, decode, execute and write back, and second instruction is branch instruction, and it is a conditional branch. So, it will be fetch, it will decode and it will execute, but while decoding the next instruction after the branch, in earlier example that is INC R2, so that will be fetched, and while executing E2, so D3 will be continue, that means third instruction will be decoded and the I4 will be fetched. After that, here is the second instruction will realize after computing execution part, it will realize that where to be jump. It realized that this is a jump instruction, but where to jump, so it will be realized here after E2. So, and then jump instruction there is nothing to be written. So, therefore, write part is not there. So, one example of the conditional is I greater than equal to 3. That means value of I you have to check with 3, and in between I can also say I plus plus. Okay. So, I should be incremented. So, that is why in jump instruction up to execution part, if it is a unconditional jump. And then what happened, it realized that it is the desired instruction is IK, not I2, I3 or I4. So, therefore, it has to be neglect this one. Whatever is after decoding, you cannot execute an instruction, because execution means and write back means it will change data. Execution is also okay until or unless you write the results to the register file. So, these two has to be cancelled. So, this is something called the branch penalty. How many instruction you are just cancelling. So, this is one instruction and this is another instruction. So, that is something called the branch penalty. So, how do you solve this problem? So, they said ki you do detect whether it is a bunch instruction and you decide where to bunch. So, you do not execute the execution part, you do only decoding, do not go for the execution. So, within a decoder you keep additional hardware, so that it will decode it. So, it will realize it is a jump instruction and where to jump, that also should be there. Using that only you can reduce the branch penalty. So, instead of 2 instruction, so it is like a early detection, okay, and then you take the measures. So, it will reduce the branch penalty. So, instead of detecting at the after execution, you detect early. So, damage will be minimum. So, that is something called the that is the solution for the unconditional branch. So, therefore, I will go to the next part is something called branch. If it is, and thing is that I do not ask this silly question, I will ask from the next part. Okay. So, something called the conditional branch. Okay. This is also added the hazard. Okay. And more interesting thing is decision cannot be taken before the execution part, because it has I greater than equal to 0. You have to compare. For comparison anything, adding, comparison or anything, what you have to do? You have to go to the ALU. So, ALU is the main execution unit. So, that will only compare and tell, okay, these two part is same or it is greater than other thing. So, you cannot do before that. So, you can say, okay, you do this everything in decoding and then you can remove the all other problem, but you cannot do that, because in conditional branch some comparison I equal to 0 or I greater than 5, some condition is there. So, that condition who will execute, that is the ALU. So, therefore, you have to go up to ALU part, up to execution part. Unlike an earlier case, we stop with decoding part. Okay? And then you cannot neglect, but any instruction, any program, and if it converted to the assembly language, 20% of the total instruction is actually conditional branch. And even though actually in C there is go to statement, so which is actually unconditional jump, and everyone suggests you do not use the go to statement. Same thing you can do using conditional part, because that is unpredictable according to the programming language. People ask, do not use that one, and that might be the reason you do not know that there is a go to statement in C. So, now is something called is the delayed branch. What can is done is actually branch is delayed, but one condition is that you cannot change, if that is the basic basic idea. If you execute the instruction in sequentially, whatever the results you will get at the end of the day, it will be the identically same if you use the pipeline. Okay, you may get the result at the middle of the day, but thing is that results should be same. We cannot compromise the results. Okay. So, therefore, we will show some example. Sometimes it may be illogical, but I will explain. Okay. Here you see. So, these are the things you can go through. As I say, I do not like reading from the directly slides. Okay. So, that you can do also. Okay. It does not mean that you cannot understand without me. Okay. So, here is what you do it when you have a jump instruction. So, let us say if I equal to 0, that will be converted to the assembly language. Okay. And then what will happen? So, it will have a set of instruction, and there will be somewhere in jump instruction, after the jump instruction, while jump instruction is getting executed and next instruction is automatically it will executed, as we have seen, it will fetch, it will decode, and whenever they are going for execution, jump instruction will say, oh, this is after me, it should have been executed some other instruction. So, therefore, we are discarding those instructions. So, what is happening, that sequence if you go, so what is happening is this is a branch instruction, after this instruction is always it is getting fetched. What we can do it here, that I3 instruction we can put some useful instruction which we may not need to discard. That means, after this one we will put some useful instruction, if we allow it, so results will be same. Instead of discarding, we allow that instruction to get executed completely. However, results also will be the same. That means, result it will not affect the results. So, that is the basic idea for conditional jumping solution, that is delayed branching. How? With example it will be clear. Here you see, this is the last slide for you. So, here we have instruction shift left, register R1, decrement R2, branch is 0. That means, branch is 0 means if R2 value is 0, then there will be branch to loop. This is a condition we put, and where it will go? It will go to the loop, and after the branch there is an instruction, that instruction is add R1 R3. So, let me understand what is this 4 instruction, what is basically it is doing. So, decrement is used as a counter. So, let us say R2 value is 5, and shift left. So, we are shifting R1 to left, and then we are decrementing and checking whether value of R2 is 0 or not. That means, if R2 is 5, so it will decrement 5 times, that is all. So, simple, and it will be repeated its loop. Okay. And after that there is an instruction is called add R1 R3. Now, what happened in general? So, here branch is one instruction. While executing this instruction, This instruction is already started for fetching and decoding, as just we have seen just few minutes before. Okay. So, what you do it, we will change this one into this order. How do you do it? So, you see we are changing decrement R2 and we are putting branch equal to 0 loop and then shifting left R1. We will change from here to here. This is something called branch delay slot. After the branch instruction, whatever that location is called the branch delay slot. What we do it in branch delay slot, we will put some useful information. How it is useful? One can think is logically I am changing the program, because initially shifting was done first and now I am doing shifting after the branch. That is right? Shifting was done first, shift left and then branch will be at the end, but I am doing the other reverse thing, right? Not reverse, but not very, it seems it is not logical. Do you have objection with this part? This part? Because I am changing, right? You should have. So, here you are decrementing branch, shift was at the beginning, now shift is at the end, so not at the within the loop at the end. So, what I said is you understood this part, right? That first what is this program is doing? Basically, it is shifting how many times, that depends on value of the R5, R2. So, if it is 5, so it is shifting 5 times R1, so that is the part, and then finally adding this part, that is the program. What I did it, we change little bit. Okay. So, how we will change it? We decrement R2, branch equal to 0, shift left R1. So, actually shift should have been done first, but I am doing after the branch. Initially, if you see it looks, it will not work, result will be different. But if you go to the instruction level, each instruction how it is getting executed, you will see exactly the same results. First case it will be the stall, but second case you won't see any stalling, or stall is minimum. Okay. So, now I will go. So, now again you consider that instruction has 2 phases, it is easy to understand. Okay. 2 phases. So, first is I am executing this part, this is okay, you shift and then decrement branch and then it will problem, as you know that pipeline will have problem. Now, I am executing second part, first is decrement, then branch, then shift and add. So, first is decrement. So, it is fetch and then execute, second branch is there, it is fetching and executing. So, it is fetching and after execution it realized there might be a branch if condition satisfied, otherwise it will sequentially it will execute if condition is not satisfied. So, after realizing, within this realization actually I am executing this part. What is this part? This is very important note, you should notice it. So, after realizing, oh, there is a branch miss, means branch should not happen or branch will happen. When I realize this part after execution, because this is a branch you have to execute, after realizing this part within this what I did, some instruction is already executed. What is that instruction? That instruction is shift. Shift was must if there was branch. Okay. So, shift was must. Okay. So, that part I am putting after the branch. What will happen? After realization, okay, that was the wrong instruction. Okay. Within that it is done. So, then if there is a satisfied, means if it needs to execute once more, then what will happen? Again it will go to the decrement branch, it will again decrement it, okay, it will let it go here, and again after branch here it realize, oh, it should execute sequentially. So, obviously after that it will execute the add branch part. So, no need to discard this part, no need to discard this part. So, what I basically did it here, this part I changed little bit here, because this part is actually it was before after entering the loop, this was must, you have to execute this part and then this one and again it will go here. So, what I did it, after branch you put the shift left. So, you see there won't be any problem here. because I am not discarding this part, let it go, whether branch is taken or not taken. So, but if you use the 4 stage, there may be problem, but you can reduce, at least not pipeline is not stalled for the entire 2 time unit. Did you understand this part, or still you may have very rightly you may have objection with this one. Okay. So, how it is happening, because shift it is sequential, right, shift was beginning and then you are writing at the end and still you are saying the result will be same. Yeah, up to this slide is you are right, but after this slide I am right, because I explain here what is happening. I am not discarding the results here, you see that was the requirement for what is called smooth pipelining. I am not discarding this too, because I am whether it is branch happening or not, that will be executed. After decision, okay, if there is a branch, then again it will go. I am not discarding here, and then here when I realize that there is branch necessary, then I will go to that particular instruction, but within this time I done my work.